Hi everybody, I'm Pieter Van Schalkwyk. I'm the CEO at XMPro, and the topic for today is intelligent digital twins. I wish I could take the credit for coming up with the concept of intelligent digital twins, but we're really standing on the shoulders of giants. Dr. Michael Grieves, who is also known as the father of digital twins, actually started the concept, or in his work looking at where digital twins are going, came up with this concept of intelligent digital twins. And you can also find a great paper that where he explains the whole concept at digitaltwin1.org, and we'll also make the link available after the webinar. And I was fortunate, I had the opportunity to meet with Dr. Grieves at one of the Digital Twin Consortium member meetings, and we discussed where things are going with digital twins. And this is a diagram that he's got in the paper, and he explains kind of the evolution. And right now we're seeing quite a lot of ad hoc. So sometimes people refer to this as digital shadows, where there's one-way communication. So we've got the physical items, and that updates a digital version. So I'm creating a static repository of data. And we're seeing more and more digital twin platforms emerging where there's some replication of data going around, and the future is moving towards intelligent digital twins with things like front-running simulations and everything. So very extensive paper that explains it all. My summary of the paper, I'll quickly run through that, is we're moving from a focus on data to a focus on data flow. So the difference between a traditional digital twin, where it's just a passive repository and we're kind of taking data from a physical and just representing it in a virtual way, to something which is active and always on. So it continuously monitors the environment and the assets itself, where the traditional digital twin is more of an offline, and it waits for the physical to actuate it. So even if you think of something like airbags, there's it's as soon as an event happens on the physical, it updates the digital. On the online one, there's continuous running on the side, and it monitors, scans the environment, and based on that also creates actuation of potential actions that come out of it. With traditional digital twins, we give it a goal, and then we create KPIs and performance measures to see how well we're doing based on the goals that we've set for that. With intelligent digital twins, we can now use more intelligent approaches to make it more goal-seeking, to try and optimize, where we augment what humans are doing with AI and smarter digital twins to support that. And lastly, we have predictive capabilities, so we can predict, but it's not really optimizing. So it's not looking for certain optimal set points, operating points, maintenance intervals, those kind of things, where going forward, doing things like front-running simulation, we are able to speed up. That's what we mean by manipulate time. We can take real-time data, we can take contextual data, we can take historical data and speed that all up, and then based on that, anticipate what is going to happen and see what are the better responses for those. And a great example of front-running simulation is what happens in Formula One car racing. And XMPro is a partner with Dell. This is not built on XMPro, but this is work that Dell has done with McLaren around things like front-running simulation. So this is one of the fastest edge devices out there. It goes at 200 miles an hour or 360 kilometers per hour. And at that, it generates about 100,000 data points per second. So a lot of information that you can put together, and based on that, determine fuel strategies and a whole bunch of other things during race time. So ability to speed up, so take the data, run it faster than real time, speed it up, and then decide on certain actions. So this is the McLaren example. There's also Great work done by Amazon AWS and others on similar things. So things like, again, taking information on the vehicles, taking track information, combining all of that. You can create multiple use cases, and I think that's one of the other elements of digital twins that's quite that's not often understood. It's not about one application or use case that I'm trying to do. I can now take that data and I can actually facilitate a multiple number of different things that I can do. So multiple use cases, in this instance, a battle forecast, pitch strategies, driver performance, tire performance, exit speeds, a whole bunch of different front-running simulations that I can do. And a specific interesting one is undercut threat. So great video on the AWS website as well. But with undercut threat, it's actually deciding when to bring your car in, and also looking at what are your competitors potentially doing. So are they looking at undercutting you by bringing in a vehicle, by bringing in a race car at a certain window of opportunity? Now, in order to do that, you need to measure the real-time speed of all your other competitors, look at their wear by using computer vision and a whole bunch of things, tire wear, trying to figure out what their fuel consumption is, take all of that and run it in your strategy. So these are very sophisticated and advanced examples of front-running simulation, but we're starting to see that move into the industrial space and other areas where we are trying to do this. So from a digital twin perspective, how we make decisions is changing. As you saw in those very sophisticated examples, we can bring a whole lot of information from multiple different places. And that's really the essence of decision intelligence, where we've got external information, we've got internal information. And traditionally, what we've done with kind of the more static digital twins or conventional digital twins is really decision support. So there's a business process, there's a human in that loop, and we are now trying to give them some decision support. And traditionally, it's been dashboards, some business intelligence, condition monitoring, basic predictions as well. So again, domain of decision support. We're seeing more and more decision augmentation, where we can bring in smarts from AI and other tools. So we still have the human in the loop that make the decision, but that human is now the decision process is augmented with information that can be processed at a speed that humans can't do it. The volume of information that can be processed, again, is done at a speed that we can't do as humans, but at the end, the decision still remains with us. So this is where front-running simulations, prescriptive recommendations, is coming in, and this provides us the opportunity to create a closed loop, a feedback loop, and learn from that and kind of improve our decision making as well as improve the models that we have. And this is kind of where a lot of focus is at the moment in terms of moving towards more intelligent digital twins. But there is a future where we also look at decision automation. So once we have a high level of confidence in some of these decisions or some of these models, we can actually let the machine make the decision through business process automation and create this distributed intelligence system where we can maintain the rules and the models and everything centrally. And it provides us the opportunity to get to algorithmic business where, again, a certain number of these business processes can be done in an automated way. So if you think about fly-by-wire, which you can do with aircraft, you might be able to operate by wire in a certain envelope. Those decisions can all be made by machines. So that's the future that we see in terms of where this is all heading, distributed intelligence systems. And if you combine that with the control environments, if you look at distributed control systems and you add distributed intelligence systems, my personal view is that's probably the future of what operations will look like. Now, what does this mean for intelligent digital twins? And I refer back to the Digital Twin Consortium definition of what a digital twin is. It's a virtual representation of entities, of real-world entities and processes synchronized at a certain frequency and fidelity. The emphasis being on it's synchronized. And it helps us with decision-making and taking effective action. Again, it's about decision-making. It uses all sorts of data, and it is motivated by outcomes, and it's focused around use cases. Again, that example that I showed with the front-running simulation, a whole bunch of different use cases that are being facilitated for that, and we implement it in, it requires domain knowledge and implement it through this. So a traditional digital twin has got that synchronization. Sometimes some of the information may go back, but it's really passive. It's offline in the sense that it's waiting for the thing on the left-hand side, the physical twin, something to happen, and that will then update. That's not, and it's goal given. So I put KPIs and things that I'm trying to measure. And yeah, we can predict, but it's not focused on optimization. Going forward with intelligent digital twins, we see that decision intelligence structure that I showed a little bit earlier make its way into kind of operating on the side. So we've got expert knowledge, business rules, all the math and physics models that we have, and quite a few of those are already being used in the more decision support type digital twins that we have. We're now starting to see what is regarded as conventional AI, so regression models and all of those, but then also the new generative AI that we've seen lately, and large language models that are making its way in, and some of the more sophisticated techniques like deep learning neural networks and those. So that intelligence making its way into digital twins, and then providing the opportunity to make it goal seeking and learning and doing these front running simulations. Now the question that we get is, how do we make this happen? How do we do this? Because in order to do this, we need this thing, that intelligence that run on the side almost. And we go from where in the previous one we had information at the bottom there, we now have prescriptions that is synchronized at a different rate. So it's not just information we're sending back, we actually send a prescription in terms of what to do back. Now this could be augmented or potentially automated as well, but we have to have this mechanism on the side that continuously run. So now going from data, this requires a data flow where it continuously run on the side and interact with that. So in order to do this, we came up with a framework. As organizations are considering, how do we move to intelligent digital twins? Well, first of all, it needs to be integrated, and it needs to be based on standards, models, and have that bi-directional integration that I mentioned. It needs to have intelligence, and we'll go into each of these in a little bit more detail, but it needs to be executable. So it needs to be able to run in real time. We need some way to make it innovative and for experimentation and doing those simulations. But we also need to provide an environment where we can bring in the help from the digital twin side and augment so that we can learn from that. And lastly, we need to make it interactive. So this is about the visualization. So how do we provide recommendations? How do we make it in a generative multi-experience user interface? Because all of this is becoming the foundation for the industrial metaverse, whatever the metaverse looks like when it comes out. In order to do this at scale, we also need to do this on a composable kind of framework where we can reuse components, almost like the Lego blocks that kids build toys with. You can actually reuse components and have a pluggable, composable approach for this. So if we briefly look at the integrated side of things, standards-based APIs for these capabilities that we package together, a model-driven approach and bidirectional. In order to do this, again, this is about data flow. So example that we're showing here, this is our data stream designer, is being able to create standard integrations to the APIs of different systems, then being able to create a model. Now, the benefit of this is I can apply this to 100 wind turbines or 1,000 wind turbines. It's exactly the same model. So in terms of the data model that supports it, and potentially the digital twin model, also model driven, but in terms of creating the logical data flow structure, making that model driven. And at the bottom right, it's not just about receiving information one way, but also sending information back and potentially changing set points based on recommendations that could come from AI and some of the other elements. So that's from an integration perspective, making it more intelligent, where we now adding this capability. First of all, in terms of those three elements, we need to make it executable. We need to provide an environment to create these AI elements, and then we need to augment the user experience with that. And again, different audiences which this applies to. So if I look at that executable, how do I bring it into the data flow? Traditionally, we would take real-time data, we would have a model, and so we've got a streaming agent that would bring in real-time data. We've got a configuration of what the flow looks like, and that just gives us a result. With executable AI, we can create a training model, and I'll briefly show an example. We'll create a training model using in this instance, our XMPro AI notebook. Deploy that model into an ML ops environment, because again, we need to now look at how do we do this at scale. If I've got tens of thousands of models, how do I do the model management as part of the digital twin management as well? And then bring that model in through, again, an agent that's got the intelligence, bring in live data that can now run on that trained model. And again, in our no-code environment, you can configure all of this, and that will give you the prediction and simulation. So what does it look like when you actually do it? What you can see here is a very basic where we're reading tank state, and you'll see where the yellow perform machine learning analysis. That actually calls a beer quality model that sits in through ML flow, which is the data repository for the model. So that's how we make the digital twins executable in the data streams that we have. The next part is to be able to bring in an environment where we can make it more innovative. So we've embedded Jupyter notebooks, but we've added some functionality to that. So you can wire it up into our data streams, but you can also integrate it with things like ChatGPT and others to help you in the process. So again, aimed at, on the one hand, analyzing the data, but also building models for things like front-running simulations and some of the others. In this instance, I've got ChatGPT here, and I can ask it to create the code for me, which is the next part over here, to create the code for me to represent this data in a certain way. So having the request having the request here through ChatGPT, how do I visualize this data? It then writes the Python code for me, and if I run that, it gives me the visualization. Here's another example of embedding or augmenting the user experience. In this instance, there's a co-pilot. So we ran this, and based on the recommendations at the top, we can see that there's potentially a impeller problem, but I can also see my discharge pressure is not what it should be. So I can ask, what are the top 5 root causes for a centrifugal pump if there's a loss in discharge pressure? And you can see what it came up with. If we have time, I'll briefly jump into showing you what that is towards the end. In actual fact, let me quickly do that. So this is the Jupyter notebook with the embedded ChatGPT. So if I just briefly step through that, I'll just do that quickly. Let me just do that. So I can run through this. It'll generate data for me. And this is machine generated data. And now I ask ChatGPT to actually create the, so let me move down a little bit. So I'm now going to ask ChatGPT to create the code for me to visualize this data. And there it's done that. And now it's created based on the code that it's created for me in Python automatically. Also created the visualization. And again, this goes into more actually putting this into ML flow. On the other example that I briefly mentioned, so on the oil refinery operations, and I just go to that pump, which has got an issue, and you can see the normal information that I have. I've got all the contextual information, but I also want to ask it a question now. I'll just, what are the top 5 root causes? And this then interrogates using functionality of ChatGPT to do that. So that's ways that we can bring intelligence to it. Lastly, on the interactive side, to make it more accessible, in terms of providing recommendations, again, the intelligent digital twins have the opportunity to not just tell you what is wrong, but also give a recommendation on what you should be doing, triage instructions, and some additional context around what happened in the past. This gives you the opportunity to also close the loop. I can create work orders and things from here, and then be able to track that as well to see how effective we are at making certain decisions. In terms of creating a collaborative environment, as the previous example which I briefly showed you, you can create very collaborative environments and user experiences where you now bring that intelligence into a front end that users can use. And as I mentioned, going forward, this will form the foundation of the industrial metaverse. Now, the brewing example that you see here is actually an example that we built out for the Dell validated solution for the manufacturing edge side of things. But this is what we see going forward in terms of creating a metaverse in a very interactive environment where, and it doesn't matter what your user experience is, whether it's AR, VR, desktops, mobiles, the intelligence is portable across all of those environments. Lastly, and on the composable side, we came up with the positioning XMPro as that composable platform, and bringing in data from all the underlying systems to be able to build out those various different use cases. And for that, we have a whole bunch of modules that support that. So in order to do that, the basis for all of that is capabilities. And inside Digital Twin Consortium, we were instrumental in creating the capabilities periodic table. These are all capabilities that we see at a really high level that is used for digital twins. If you want more information on the Digital Twin Consortium website, you can download the whole capabilities framework. We also have a webinar that we've done in the past, which you can have a look at, where we go into the capabilities and composability side for that. So here's our view. in terms of what the future looks like, or sorry, the components that you need in order to create intelligent digital twins, which we see as the future of where digital twins are going. We've bundled that all into what we call the Intelligent Digital Twin Suite. XMPro IDTs consists of a number of modules, and happy to share more information on that. Just lastly, we also see that this way, in terms of where we are going and how we're doing this, that line in future may disappear, and that intelligence all being built into the digital twins of the future. So with that, there's a few minutes left. Any questions that anyone's got that I can address?
Hello, Peter, Gavin here. Great presentation. You do have a few questions that came up there. To take it from the top,
one of the questions that we get is, do you supply the AI models? It is the reason why we created that environment. So inside the XMPro AI notebook, you can create your own models. There are libraries of existing models. There are auto ML. There's a whole kind of continuum of opportunity to use pre-made libraries of models. We don't specifically do models, but there's a large library of simulation models of all the standard traditional AI models, as well as you saw, being able to bring in generative AI and others pretty easily. How do you get started with this? We're happy to run you through kind of the kind of three-step process on how to get started with these digital twins. But hopefully that's been helpful in giving you an understanding of what we see as the future and what intelligent digital twins will look like going forward. Any additional questions? I have one question that was sent to me around. So yeah, again, this is, I think, the way that we look at how to create this. We look at it, it needs to be integrated, it needs to be intelligent, it needs to be interactive, all on a composable approach. And then in terms of the question is really, are there starters or examples? We have blueprints that we are creating. They are starter examples. They're all in GitHub, so really easy to export into your environment and then play with it. We do have a freemium option, so if you go on our website, you can download freemium option of our software, and also some of these libraries and examples that we have. Well, with that, thank you very much. Really appreciate you watching this, and we'll see you on a future webinar. We will send out the recording of this after the event. Thank you.